Hello, am I audible to everyone?
हाँ मैम.
Okay. So, students, I welcome you all for today's GATE class under Prerna scheme sponsored by AICT. Today's lecture will be on concrete structure, in which you are going to study about working stress method, limit state design. This topic is very important for GATE classes. So I request all of you, please pay attention. Today's lecture will be presented by Professor Suyog Dhote sir. I welcome sir. I welcome you, sir.
Thank you, ma'am.
Okay. So now, sir, you can proceed with your lecture.
Okay, ma'am. Am I audible?
Yes, sir.
Okay. Okay. So very good afternoon to one and all present here. Okay. So dear students, please prompt me. Am I audible to you? And is this screen is visible to you?
Yes, sir.
Okay. Thank you. So today we will do see what are the concrete structures. Okay, and in that what are the different methods to design a concrete structures. Okay, what are the different method to design the whatever is the elements present in a concrete structure. We will see that methods. Okay, and again we will see the different fundamentals behind this designing of concrete structures. Okay, so before going to designing of these concrete structures or whatever the methods are available for these concrete structures, before going to start that designing portion or that methodology, before that we will see in a we can say in a fast manner what are the different materials that are used for the construction of concrete structures. Okay, so there are several materials, we all aware about that. That are several material like the cement we are using, then the aggregates we are using. In aggregates we are using the coarse aggregates, as well as we are using the fine aggregate. Okay, as well as we are using the water. Okay, so for making this concrete we are using these kinds of, we can say, binding material, some of the kinds of aggregate, and for we can say to create the binding nature. Okay, so we are using the water in it. Okay, a domestic water we are potable, sorry, a potable water we are using it. Okay, maybe you are aware about or not, I don't know, but you should aware that whatever kind of cements we use, okay, for different kinds of purposes. So for different kinds of purposes, what kind of cement we are using, okay, that particular knowledge we should have. Okay, because if we think about the concrete structures, the designing portion, it is okay. Okay, the methodology whatever is available behind the designing portion, it is okay, it is again okay. Okay, whatever is the design parameters are there and what are the different methodologies are there, we will again go through it. Okay, that's fine. But in terms of concrete structures, what are the different materials that are used? Okay, because whatever is the methodology we study in this design of concrete structure, all the methodology deals with the whatever is the material we are using, okay, for making this concrete structure, as well as what kind of workmanship we are using for the making of that concrete structure. Okay, so in a definite way we should aware that what kind of different cements we should use for going to construct these concrete structures. Means there are several types of concrete structures, like we have to design the residential building, we have to design a commercial building, okay, we have to design a bridge. Okay, and after this, these are some of the kinds of structures. Okay, in the commercial kind of structures, there may be some of the kinds of institutions are there, some of the kinds of hospitals are there, and any other some of the kinds of theaters are also there. Okay, apart from these there may be some of the kind of marine structures are there. Okay, so like these are some of the structures, some of the structure like factories, or some of the structures like chemical factories where the chemical are prepared, or we can say these structures more susceptible to chemical attacks. Okay, so in general there are several, we can say, aspects where we have to use different kinds of cements. So at least we should know this. If I have to go for this normal construction, say if I have to go for the normal residential construction, what type of cement I should use. Okay, then if I have to go for the any foundation work, okay, any massive concreting work, then what type of cement we should use. Massive construction, like if I have to use in a foundation, or if I have to use in dam. Okay, so like these are some of the kind of massive in dams. There are these, this is the kind of massive concreting, okay, massive concreting work. So in that fashion, what type of cement we should use. Okay, because all the methods are deals with the whatever the strength parameters of the material that we are using for the particular designing parameter. Okay, in this concrete structure, the basic binding material that we use is the cement. Okay, so we all should aware about the what are the different kinds of cements that are available in the market. Okay, as well as we all aware that about if we take the any of the aggregate or any of the parameter, we have the building we have the BIS standards, Bureau of Indian Standards, that specify that these kind of material we can use, and what is the, and this is the some of the kind of standard characteristic strength for the particular material. And again, this will provide some of the kind of specific use, okay, for the, we can say, the specific purposes. Okay, and all these, we can say, all the kinds of information, required information for any kind of, we can say, binding material or any kind of material that we are using. Okay, not only in concrete structures but also in the different kinds of material that we are using in civil engineering aspects. Okay, so these all the materials, okay, all the workmanships also, there are the BIS codes are available. Okay, so like if you have to go for the general construction, then ordinary Portland cement we are using. Okay, and the for ordinary Portland cement we are using the IS 269 1976. Okay, so this is the basic IS code that is used for ordinary Portland cement. Okay, and as a preparation of this gate, we should aware that for the basic purposes, what are the different basic purposes in civil engineering, and what are the different basic uses of cement for that respective purposes. At least we should know. Okay, apart from these design parameters, so if the dam constructions are there, means massive concreting structure, massive concreting work is there, then we are using the low heat cement. Okay, then again the same IS code, IS 269 1976 we can use. Okay, then for quick removal of formwork, maybe in the some of the cases there may be we can say due to lack of time or anything. Okay, you may have to go for the any quick setting of cement. Okay, any rapid hardening of cement. Okay, or quick removal of, we can say, form work. Okay, any bridge construction is there, and there may be the heavy density traffic is there, and you have to go for this, we can say, the form work, and you have to quickly remove this form work. Okay, in some of the cases, so we can go for this rapid hardening cement. Again, the IS code which is used for rapid hardening cement is IS 8041 1990 1990. Okay, so like these are some of the kind of, we can say, uses. Apart from these, there is some of the structures that are susceptible to chemical attacks. There we specifically use Zolana cements. Okay, again, IS 1489 is the basic choice for the particular Pozzolana cements. Then there are several prestressed concrete. If we have to go for the prestressed concreting, then there will be some of the kinds of high strength cement we are using, and IS 8112 is using is available for providing the details about these high strength cements. Then if we see about the hydrophobic cement, okay, so whatever is the waterproofing compound, waterproofing construction is there, or we can say the marine structures are there, for that purposes we are using the hydrophobic cement. And for that purposes we are using, or whatever is the IS code is available, is IS 8043. Okay, so in general, this is the meaning is the outcome, or we can say the objective of telling these different kinds of cement, because we are discussing the concrete structures. And the, in concrete structure, cement is a basic material used for the binding purposes. Okay, and we should know these different kinds of cements. Okay, then there are some of the kinds of, we can say, grading is cement, grade 33 grade cement, 43 grade cement, and 53 grade cement. Okay, and again there may be some of the kinds of IS codes that are also available. Some of the kinds of IS codes are similar to the IS code for use for the types of cement. Okay, in that particular IS codes also some of the kinds of mix are also provided. Okay, so by referring to that IS codes, apart from these, we can say the basic IS code that is used for these concrete structures are IS 456. So apart from this IS 456, these are some of the IS codes that we can use for the concreting purposes. Okay, then there will be some of the kinds of aggregate, and for the aggregate we use the IS code like IS 383 1970. Okay, this is the IS code which is used for the aggregate purposes. Maybe the aggregate may be of, we can say the coarse type of aggregate, or we can say the fine type of aggregate. Okay, so for that purposes, some of the kinds of IS codes that we are using is the IS 383 1970. Okay, so generally these are the some of the, and we can say the coarse aggregate which we are using for making the concreting or concrete. Okay, so it is a hard blasted granite chips which are using, okay, for making the concrete as a coarse aggregate. Okay, then fine aggregate, if we say this fine aggregate, the medium sand for grade 2 as per IS 456, okay, we are using. Okay, so this is the kind of fine aggregate we are using. And after this, some of the kind of potable water, okay, we are using to make prepare a mix. Okay, after this we are using some of the kind of admixtures there, okay, to provide some of the kind of property, to enhance some of the kind of property, to retard some of the kind of property. Okay, so some of the kinds of retarders are there, some of the kinds of accelerators are there, some of the kinds of plasticizers are there. Okay, so depending upon these different admixtures that are used, if we use the retarder, that delays the setting time of cement. Okay, if we use the accelerator, it will increase or accelerate the sitting time of cement. There's some of the kinds of plasticizer that keeps the cement in a plastic state for a longer duration. Okay, so depending upon the, we can say the retarder, accelerator, and some of the kinds of plasticizer, specifically plasticizers are used in the, we can say, these concrete mixers. You can see the concrete mixers are running on the road. Okay, and some of the kinds of, we can say, mixing station is available at the one point, and this concrete is provided at the another end. So for this kind of travel and for this kind of duration, the concrete should be in the plastic state, and in that case this specifically these plasticizers are comes into picture. Okay, so these are the some of the kinds of, we can say, admixtures. Apart from these coarse aggregate, cement and water we are using, okay, so to enhance the properties of concrete. Okay, then water, then if we say the water, I am not going in detail this water, that there are several parameters we study in the water, that organic solids and sulfates and suspended matters and all these, inorganic things and all these things. Okay, the pH value and all these things that are available in the our IS codes, we can go through it. Okay, but before going to any competitive examination, or we can say the gate preparation, all of you, all of us should know this, what are the different properties or what are the different values that are available for, say, if you say the in a particular type of water, what kind of organic matter is present, and what is this permissible limit for organic matter in a particular water. Then if it says the pH, then what should be the pH value for the use of this water to make a concrete. Okay, so like these are some of the property that are available in the IS code. Okay, so in general, we can say these are some of the kinds of material, okay, that are used for the making the concrete. Okay, so apart from these, this is not the our, we can say, the basic target for today. The today's target is like different. We have to study this different parameter, like what are the different design aspects for the designing of these elements, this we can say structural elements. Okay, we all aware about there are two types of structures, the load bearing structure and some of the kind of frame structures. Load bearing structures are outdated nowadays. Okay, and whatever kind of structures we found or whatever kind of structure we design nowadays, these all the kinds of structures are framed structures. And this frame structure consists of, say, foundation, then the column, then the beam, then the slab. These all are the elements of these framed structures. Okay, so we have to study these different kinds of designing parameters came behind this, we can say, design of beam. What are the different types of beams are there, and what are the different methodology available to design a beam. Okay, then what kind of slabs, what is the one way slab, what is the two way slab. Okay, what is the short column, what is the long column, what is the specific use of these kinds of column, what is the influence of these kinds of columns. Okay, what is the influence of one way slab, what is the influence of two way slab, when we should go for the one way slab, when we should go for the two way slab. Okay, what is the this, what is the aspect ratio and what is the criteria. Okay, what is the ly by lx ratio and it why, what it should be. Okay, these are the some of the kinds of elements we have to design, and all the kinds of this we can see the theory portion behind this, all the kinds of beams, slabs and columns, as well as the footings. Okay, so all these parameter we should aware about. Okay, then in footings, if we think about the footing, then footing, there may be some of the kinds of isolated footings. In isolated footing, there may be some of the kinds of slope footing, it's some of the kinds of step footing, some of the kinds of, we can say, in a common footing, or we can say the combined footing, there may be some of the kind of rectangular footing, there may be some of the kind of trapezoidal footing, or we can say some of the kind of mat footing, some of the kind of raft footing, or some of the kind, maybe in the some cases where the soil bearing capacity is very much lesser, there, for that condition we will go for this pile foundation. Okay, so these all the kinds of foundations. Okay, all the kinds of these columns, maybe the column in a, you can say, cross sectional parameter or cross sectional wise, the columns maybe comes into the rectangular column, the square column, or the circular column. Okay, again, if we think about the slab, there will be the significantly, there will be the one way slab, the two way slab, and the thickness of the slab. Okay, again, if you think about the beams, then in the beam there will be the singly reinforced beam, there will be the doubly reinforced beam. Okay, there are specifically the two types of beams. Okay, again, if we think about the what is the methodology behind designing these beams, there will be some of the kinds of three methods. Okay, some of the very first is the working stress method, another is the ultimate load method, and this third is the limit state method. But here I have shown this only to two methods, that is the working stress method and the limit state design concept. Okay, because these two methods are very much we can say user friendly, or we can say very much used by the people. Okay, and first of all, this working stress method is used by many people to design these beams and whatever beams specifically. First of all, we will think over the beams. Okay, and in terms of beam, if we think, so in the previous days, in the previous years, many people used this working stress method to design these beams. Okay, then he found some of the kinds of advantages behind this working stress method, some of the kinds of major disadvantages behind this working stress method. Okay, some of the people thinks that some of the improvement is necessary for this method. Okay, and what kind of improvement is necessary, what kind of we can say, what kind of results they found. Okay, and on this result, what kind of interpretation they did. Okay, so all these criterias we will discuss further. Then after that, after working stress method, there is the limit state design concept. Okay, so depending upon these, what are the criteria available in working stress method. Okay, so some of the kind of improvement over this working stress method, so it is came with this limit state design. Okay, so limits at present whatever kind of frame elements are there, the concrete frame elements are there, all the kinds of frame elements are designed with this limit state design concept. Okay, so first of all, we will discuss this, what is the working stress method. Okay, so for the content, these are some of the content for today, but maybe in the this 1 hour duration, what we can say discuss. Okay, we will see. So first of all, we will discuss the working stress method and what is the meaning of working stress method. Okay, see, this method is very used in a very vast. Okay, in the previous years. Okay, so because of this means after the load bearing structure, what kind of frame structures are available and what kind of methodology used for the designing purposes, this is that is the working stress method. And that's why in the major of the time, whatever the old structures are available or are there in the our society, they are built with these working stress methods. So that's why this method is termed as the traditional methods of design. Okay, but nowadays this method is not used. Okay, this is the, we can say, at present in 2021 it is the outdated method. Okay, but still we are because we are in the phase, because we have some of the kinds of structure that are designed with the this working stress method, and at present we are designing the present structures with the limit state design. Okay, so there are the many case study that gives the difference between this working stress method and limit state method. That's why it is the goal to study that what to understand by this working stress method, and what are the significant improvement over this working stress method. So here in this method they assume some of these methods are based on some of the kinds of strong assumptions, and a very strong assumption, maybe that assumption is not purely good. Okay, but these assumptions is there. So second statement is like assumes that the structural material behaves like a linear elastic manner. Okay, now when this term linear elastic, or we can say this elastic manner, comes into picture, you may aware this concrete is very weak material. Okay, if you apply a tensile force on the concrete, you will find this concrete ro dega. Okay, so concrete is not made for that kind of load. Okay, if you go for the compressive load for the concrete, it is okay, he will sustain. Okay, whatever kind of compressive load is there, the concrete will sustain. Okay, but we all aware that concrete is not elastic material, it is a totally brittle material. Okay, the concrete is not the elastic material, it is totally the brittle material. But in the working stress method they have the assumption that these all the whatever is the structural element we are thinking of, these structural element behaves like a linear elastic manner, in a linear elastic manner. It is not perfectly good, it is not perfectly right. Okay, so this is the, we can say, the assumption. And what why we are providing the reinforcement in the concrete, because we all aware that the concrete is weak. Concrete is a brittle material. Okay, and whenever this brittle material breaks on the application of load, it will not give any significant we can say any significance idea to before the failure. Okay, गिर जाएगा, झट से गिर जाएगा, मतलब पता भी नहीं चलेगा अगर आप लोग रात में सोए हुए हो तो गिर जाएगा अगर if you don't go for this reinforcement in it. Yes, whatever is the reinforcement we provide inside these concrete member, the purpose of providing the reinforcement inside the concrete member is to provide the elasticity. Okay, so like the, if we think about the real aspect for this kind of, we can say for example a beam, in a beam we are casting beam with concrete, and we are providing some of the kind of reinforcement in it. Okay, so concrete will behave like a brittle material, whereas this steel will behave like a elastic material. Okay, so the steel will provide some of the kind of elasticity to that particular element. So in the design of beam, we will say that this concrete is a brittle material, but to improve this brittleness property, we will provide some of the kind of reinforcement in it. Okay, then there may be some of the different kinds of reinforcement we have. Mild steel is there, then the torr steel is there, like this. Okay, then there may be some of the kinds of steel wires are there. Okay, depending upon the purposes. If we have to go for the prestressed concrete, then we are using the wires. If we go for the normal any beam design, then we will go for the torr wires. Okay, if I have to bind some of the kinds of torr wire, then we will go for the mild steel binding. Okay, so like depending upon these different kinds of we can say steel, the basic different kinds of purposes are there. Okay, so depending upon these, means whatever is the actual condition, the actual condition is like concrete is brittle material, steel is a elastic material, but whereas in the working stress method the whole we can say whole element is assumed to be in elastic material. Okay, so this is a basic assumption, this is totally wrong, which is totally wrong. Okay, and again whatever is the loads we discuss, sorry, whatever is the load they have decided. Okay, or whatever is the load they have decided in the designing property or designing procedure. So that are the working loads. Okay, see, there are two kinds of loads. First is the working load, second is the ultimate load. Okay, now the thing is, working loads like these are the some of the kinds of actual loads. Okay, means whatever kind of actual load is coming on these some of the kind. So for example, say if a beam, if I consider the beam, over the beam there will be the slab. Okay, so over the beam there will be the dead weight of the slab. Over that there may be some of the kinds of equipments, or we can say if we consider the classroom, then there may be some of the kinds of, say, the benches that are available on that particular slab. What a kind of students sitting over that, we can say over the slab with this desk and benches. Okay, and apart from these, some of the kinds of cupboards and all these things, that all are comes under the live loads. Okay, and there will be some of the kinds of live loads, and this will be some of the kind of dead load in the form of this dead weight of the slab. Okay, that all the weight will come over this beam and get transferred to the column, and from column to footing. So this will be the, we can say, this flow. Okay, but whereas whatever is the load coming there, okay, means, for example, if we are designing a particular classroom, if we are designing a particular classroom having the capacity of say 40 students. Okay, so for that 40 students, whatever is, yeah, I will consider the weight of each student. Approximately I will consider the weight of each student is 60 kg. Okay, so around 60 kg or less than that. So major at the extent limit the weight will be 60 kg. So 60 kg, okay, I will convert into newtons, or I will put on in the kg itself. Okay, and I will calculate the whole load for the 40 students. Okay, that will be the one parameter. Another parameter will be what is the, we can say, what is the system we provide. Okay, not a system, we can say what is the arrangement we have done for their sitting. So some of the kinds of desk benches are available. Then what we will measure the one of the single desk and bench, this we can say assembly, what is the weight of that. Okay, and again I will calculate for weight for the 40 desk benches assemblies. Okay, again I will add both the weights. Okay, apart from these, there may be some of the kinds of amenities that are available in that particular room, some of the kinds of cupboards, some of the kinds of dais. One faculty, the load of that particular faculty, the load of that dais, artificial dais, and sorry. So all these kinds we will calculate, and for the particular load, I will go for the design. Okay, say whatever is the kind of load. Okay, say some of the kind of load is XY kilonewton is comes into picture. Okay, say for example 60 kilonewton load is coming on the particular structure. Okay, so 60 kilonewton load is coming. Okay, 60 kilonewton per meter square load is coming. Okay, for the particular area. So I will design my structure for that particular 60 kilonewton per meter square load only. That will be my working load. That will be my working load. But when I consider the what is the load coming actually on the beam, or coming off actually on that particular floor, I will assume some of the kind of more load than this load, actual load. That will be my ultimate load. Okay, so there may be some of the kind of, say, factors, multiplication factor will be there, and by multiplying that particular factor I will increase this actual load to some of the kind of higher load. Means I will assume that at present it has the capacity of 40, but in future it may happen that I have to go for say 60 students, I have to go for the 80 students, I don't know, because my intake at present, my intake is 40, it is fine. Okay, but maybe depending upon the, we can say, depending upon the whatever is the, we can say, the development in the further coming years. Okay, there may be some of the kind of rise in the intake. Okay, so there may be some of the kind of intake to 80 students also. Okay, in that case I can't break the structure and again rebuild the structure, it is not feasible. Okay, so first of all we have to think over the what is the actual load coming on the structure, and for that purpose we should go for the higher sided. Okay, but whereas this, when we go for the working stress method, This is not the case. Okay, this is not the case. If we think about for the at that time, if we think about the 40 students load, okay, only 40 students load will be taken into account, and the particular for the particular value of load we will going to design that particular structure. That if that was the concept in working stress method. Okay, that were the working loads. Okay, then the specified permissible stresses are kept below the material strength. Okay, again see material strength is came into picture. Okay, now specified permissible stresses. Okay, now because when we use a particular material, when we use a particular material, the particular material have a particular significant strength. Okay, and whatever load is applied on that particular material, some of the kind of stress, the load per unit area means some of the kind of stress is generated for over that particular material. Okay, so they assume that whatever kind of stress is developed in that particular material over the particular material is kept within the permissible limit. Okay, it is the again it is the assumption. The specified permissible stresses are kept below, or we can say they will specify the permissible stresses for the any kind of material. Okay, lower than the exact value. Means for example, if a particular aggregate is having the particular strength, okay, then they will assume the strength will be slightly or some of the kind of lower value than the existing. Means some of the company or some of the kind of firm is providing say sand. Okay, standard sand is providing, and he will specify some of the kind of characteristic strength for the particular use of sand in a compressive loads testing. Okay, so in that case whatever is the value they have provided for the designing purpose, whatever is the value we assume slightly lower than the that permissible value, we will take into this account, so that whatever is the we have the structure is there, that should sustain in the several further in their in his life cycle, in his life. Okay, further total life. Okay, the design usually results in the relatively large section of structural members. Okay, now what we are doing, we are considering the working loads, we are considering the actual loads, we are considering the strength of material lower than this actual strength value. ओके, मीन्स आप लोगों ने जो मटेरियल लिया था वो अच्छे क्वालिटी का होगा, लेकिन आप लोग जो मटेरियल का स्ट्रेंथ आप एज्यूम कर रहे हो वो खराब मटेरियल की वैल्यू एज्यूम कर रहे हो। तो उससे क्या होगा, उससे आपका जो आपकी जो लोड की वैल्यू जो है, लोड की वैल्यू पे आप लोगों को जो परमिसिबल स्ट्रेसेस आप लोगों को मिलने चाहिए वो प्रॉपरली नहीं मिलेंगे। ठीक है, इन दैट केसेस what is the we can say the what will be the significant we can say these sections should be there, that will not be there, and that will results in the some of the kinds of large sections. Okay, so sustain that kind of load, to sustain that kind of load we have to go for this large section. I mean for say if maybe for the same kind of load 300 by 450 meter का beam अगर sustain कर रहा होगा, तो by using this method it may be extend increase up to say 300 by 600 mm. That may be the case. So again the large, we have to go for the large sections in this working stress method. Steel and concrete act together elastically, where the relationship between the loads and stresses is linear. Okay, it is not. It is again the assumption. It is not the correct thing. Okay, steel is a we can say this is the ductile material. It will behave differently, whereas the concrete is the brittle material. It will behave differently. Whereas they are giving the assumption that the steel and concrete will act together and will behave in an elastic manner and will give the some of the kind of stress and relation, and that will be linear. Means that they are saying that this concrete and steel are means whatever the significant characteristics of steel is, that are the same with the concrete, but that not be the case. So this method is basically based on the some of the kind of these assumptions. Okay, so this is the sum of the kind of we can say this is the sum of we can say stress strain relationship. Okay, so this is the sum of the kind, this is the beam. Okay, this is the width of beam, so b, and this is the we can say the total depth capital D, it is uh, it is every time it is denoted by capital D. This is the standard, we can say, notation used to denote the overall depth of the beam. Then at this side there is the small d. Okay, the small d is used to denote the effective depth for the particular beam, and the effective depth is taken from the upper extreme fiber to the center of the, we can say, in reinforcement provided at the bottom. Okay, uh, so this is the, we can say, effective depth. And for that particular means from the upper fiber and up to the center line of the, we can say, the reinforcement, up to that we will see the whatever is the stress strain, we can say, representation. Okay, so they have the basic assumption that the concrete as well as steel will behave in a same manner and will provide some of the kind of elastic responses there. And that response will be in the, we can say, linearly straight line. So this is the linearly straight line, but that will not be the case. And again, whatever is the kind of neutral axis, okay, means whatever is the stress developed in the concrete, that will be the same stress developed in the steel. Okay, so this is the basic assumption behind this working stress method. Okay, so like this is provide the neutral axis exactly at the center, and this triangle 1 and this triangle 2 will be the same. That will denote whatever is the kind of stress generated in concrete, that what is the stress generated in concrete, that is the same stress generated in the steel. Okay, so T stands for the tensile and the C stands for the compressive. When we assume some of the kind of beam, okay, so on the application of load over this beam, there will be some of the kind of slab. Okay, some of the kind of slab, and there are some of the kinds of load. Okay, and on the application of this load, the beam will try to deflect in this manner. So beam will try to deflect in this manner. Okay, so like this manner means this, so upper portion will be in compression. Okay, many of the students are get confused in this parameter, where is the compression and where is the tension. Always please remember, compression is at the top and the tension is at the bottom. Okay, so because when this load is applied on the particular beam over the slab, okay, whatever is the kind of load is coming in the downward direction due to due to these loads, okay, this is the, we can say, deflected shape of the particular beam. Okay, and over this you can see these upper fibers are come closer on the application of load, whereas the bottom fiber will move apart on the application of that load. Okay, so here there will be some of the kind of, this is a tensile in nature. Okay, stress होगा, और जबकि ऊपर at the upper extreme fiber there will be some of the kind of the loads like ये contract होगा, so this is under compression and the bottom is under tension. That's why we are providing the reinforcement at the bottom. That's why we are providing the reinforcement at the bottom. Again, there is the another, we can say, reason behind that, because we know, all are aware, that concrete is weak in tension. Okay, concrete is weak in tension, and where the tension is reflected in the concrete, at that location we have to go for the tension, we have to go for the reinforcement. Okay, so tension for the particular kind of beam, okay, so it is a traditional conventional beam. So for the particular kind of beam, for that particular beam, the tension is at the bottom. Okay, again the concrete is weak in the tension, and for that purpose we are providing the reinforcement at the bottom. That is the reason to provide the reinforcement at the bottom. Many of times students don't know why this reinforcement is provided at the bottom, why not at top. Okay, many of times students don't know really. Okay, so ये रट लेते हैं कि जो रेनफोर्समेंट होता है वो नीचे ही होता है, उनको पता ही नहीं होता कि नीचे क्यों होता है. ठीक है, व्हाट इज द रीजन बिहाइंड दैट. ओके, सो कभी भी ध्यान में रखना, concrete is weak in tension, concrete is a brittle material. Okay, and wherever we have to go for this tensile stresses in the concrete, then in that location or in that cases we have to go for the reinforcement detailing. Okay, and where at which location there will be the tension, for that particular location we have to go for the reinforcement, because reinforcement is the another, again in the form of steel, and again the steel is a steel is a ductile material. It will again will behave in a better way in this under the application of this load. Okay, so that's why we are using this kind of reinforcement at the bottom. Okay, so on the application of load, whatever kind of strain developed at the uppermost fiber, it is the standard value, it is the 0.0035. It is the value of strain. This is the strain diagram, and this is the stress diagram. Okay, so whatever is the kind of triangles, okay, apart from this stress diagram, whatever kind of triangles are again developed or generated in the strain diagram also, okay, that shows the similar kind of stresses are developed in the concrete as well as in the steel. This is again the basic assumption. Okay, and there will be some of the kind of formulation to calculate this neutral axis, again to calculate this whatever is the kind of compressive force here and some of the kind of tensile force here. Okay, so this is the some of the kind of formulation. Okay, these are the standard formulation that are available in many of the books. Okay, you can refer it, and these are the standard formulation. Does not change. Okay, so once you practice this formulae, okay, each and every time in the working stress method you have to use this these formulae. Okay, so this is the, we can say, this is the, we can say, the compressive force. Okay, this 0.7 fy, 0.87 fy is the value of say T, and this value of C is half fck bx square. Okay, so this is the formula used for the compressive force. Okay, so this is the some of the kind of, we can say, this is the stress strain relationship for the beam that are used in working stress method. Okay, apart from these there is a, some of the kind of, we can say, stress strain relationship is provided. Okay, but in case of from where to where it is, we can say, elastic limit, from where to where it is in the plastic limit, and where to where it is in yield limit, or we can see in the yield position, and wherever is the breakage, depending upon these different kinds of material. If we say the concrete, so in concrete maybe this some of the kind of stress relationship like this. Okay, in case of, we can say, in a steel, some of the kind of stress relationship relation like this. Okay, so some of the kind of linear relationship, whatever kind of force you apply, the say the in the similar quantity of strain, or we can say the stress you can find. Okay, so this will be the, some of the kind of linear relationship. That linear relationship is within the elastic limit. Okay, again, because due to this elasticity, whatever kind of load you apply, the same quantity of deflection or displacement is there. Okay, so that's why whatever kind of load you apply, similar quantity of this deflection or the elongation is there. So up to A, so OA is within the elastic limit. After this there will be some of the kind of plastic state from A to C. Okay, and after this some of the kind of D is the some of the kind of, say, uh, plastic point. Okay, it is a partially plastic state from B to F. Okay, it is a partially plastic in state. Okay, and after this some of the kind of E will provide some of the kind of yielding point for the particular material, some of the kind of, say, steel, and at F it will break. Okay, so this will be the some of the kind of longer, we can say, nature that will provided by the steel, whereas in the concrete it will break in the plastic state only. Okay, so very less elastic, we can say, behavior, and at the plastic state it will break. Okay, so like this is the some of the kind of representation. Okay, then the what are the different basic assumptions that are used in working stress method? This is the method is basically used in a by considering the many basic assumptions. Okay, like the section that is plane before the bending remains the plane after the bending. Okay, then the steel and the concrete behaves like elastic element. This we have already seen. Okay, then the concrete takes the compressive load but not takes the tensile load. Okay, again, ये अभी कैसे पता होगा कि भाई कंक्रीट है तो वो कंक्रीट सिर्फ कंप्रेसिव लोड ही लेगा और सील है तो वो टेंसाइल लोड ही लेगा? This is not the human being, this is not the living thing that we are teaching to those people, that you only take the compressive load and you still only take the tensile load. Okay, this is the assumption. Okay, these assumptions are not correct. Okay, so depending upon this assumption, is method is not suitable. Okay, you can say particularly, so still take the tensile load but not takes the compressive load. Again, this cannot be happens in reality. This is the, we can say, in a totally the theoretical manner. Okay, the bond within the concrete and steel reinforcement should be perfect. Okay, it is fine. Okay, so the bond should be perfect. Though the method is different. Okay, working stress method ho ya limit stress method ho, but the bond between these concrete and steel, there should be there. Okay, under working load, the stress line relationship of concrete and steel is a straight line. Okay, so this is the again the basic assumption, but that not be the case, because we are thinking of the two materials, that is concrete and steel, and again these are the, we can say, these whatever the nature of these materials are very opposite to each other. Concrete is a very brittle material, whereas the steel is a very ductile material. Okay, whereas this relationship will not be, definitely will not be in a straight line, but they are assumed that the whatever is the behavior of this kind of material used in a particular method is straight line. Okay, so this is the some of the kinds of assumption that are used in working stress method. Okay, now over this some of the kinds of, we can say, assumptions, we have seen these some of the kinds of assumption or some of the parameters that are available in these assumptions, okay, that are not good. Okay, and some of the kinds of improvements are necessary. So for that particular improvements, this method is comes into picture. Before, in between, this ultimate load is there, or ultimate load method is there. Okay, but basically this ultimate this limited state method is dependent upon whatever is the lacunas present in this working stress method as well as this ultimate load method. Okay, so these are in working stress method what we are doing. The working stress method, see how it is going to remember. I will show, I will tell you a simple trick. In this previous, it is you can read, the specified permissible stresses are kept below, well below the material strength. Okay, means what we are doing, we are first of all, in the working stress method we are considering the working loads only. Okay, and what kind of material we are using, whatever is the actual strength value of that particular material is, okay, we are assuming lower the value than the permissible value. मीन्स वी आर, मतलब अगर मटेरियल अगर अच्छा क्वालिटी का होगा, वी हैव द मटेरियल ऑफ गुड क्वालिटी. ओके, बट वी आर considering the material of worst quality. That is the case with the, we can say, working stress method. Whereas in ultimate load method, the term is ultimate load method, means whatever is the material we are using, we are not uh, touching these materials. In the ultimate load method, we are touching the loads, ultimate load, whatever is the load coming on the existing structure, we are increasing that particular load. So that was the, in this we are not touching the loads. In the working stress method we are not touching the loads, we are lowering the strength value of materials. Whereas in the ultimate load method, we are not touching the materials, but we are increasing the load value. Okay, means for the particular value of material, for the particular value of strength of material, okay, that particular strength of material value, we are increasing the load value. Okay, and again do the design aspects. Okay, so that were in the ultimate load method. Okay, and the limit state method, again the name itself, whatever is the kind of limits. Okay, in the form of, in case of materials also, in the form of loads also. So this is the perfect, we can say, we can say, improvement over these two methods. So in the working stress method, we are not touching the loads, the load kept constant, but we are considering the material having the low strength. Whereas in the ultimate load method, the name itself gives the idea, ultimate load method, we are not touching the material, we are increasing the load value. Whereas in the limit state method, it is the overcome or outcome of these two methods, in which we are thinking of the limit for the materials and limit for the load value. So whatever is the limit for materials, we are not increasing the strength value. For materials, we are not increasing, we are not decreasing the load value. Let us understand. Okay, if we think about the limit values for loads and limit values for materials, then we are not decreasing the load value, nor we are increasing the material value. because if you increase the strength value of material, if you increase the strength value of material, it may comes into bad workmanship. Because sometimes the IS code will specify this, you have to use the grade 2 sand, okay, as per IS 456, okay, it is fine. Books mein documentary, it is fine, it is available. But what about in practice? Is it available everywhere? It is not available everywhere. And in many a times, whatever is the material we are using, that having the very poor, we can say the strength values. And if we considering whatever kind of sand we have, okay, the whatever is the kind of strength we have in the IS code given, okay, and higher the value of than the IS code, if we use, your structure will be definitely falling, definitely fall. Okay, so that should not be the case. Means again, in this case, we have to think over the limit for the material, but the in the lowering the value. Means whatever kind of material we are using, though the quality of material is very good, though the quality of material is very best, but we are to use the strength value of good quality. Though the material is very best that is available at site, but we have to use, or we have to use in the design, the characteristic strength for the good material only. That is the difference. Okay, then in case of loads, whatever kind of loads we calculate for the particular kind of buildings, for the particular kinds of building, we have to increase the load. We have to increase the load because in future there may be some of the kind of rise in load be there. Okay, so like to take such a, we can say such aspects, we have to increase the load, we have to decrease the strength value of materials. Okay, that will be the limits, some of the kinds of limits for the loads as well as some of the kinds of material. Okay, so there will be some of the kind of, we can say, there are two parameters. Okay, so definite advancement over the traditional design methods. Okay, this is the some of the advancement over these two methods we have seen. Again, it will consider the two parameters, that is safety and serviceability. The safety, the safety deals with the type of loads came over this particular type of building. Serviceability will play a definite role of workmanship and whatever kind of materials that you are using for the particular structure. Okay, so in this limit statement design, we are considering these, we are assuring for the safety of the structure as well as the serviceability in the coming years for the particular structures. Okay, at working loads, at working loads, but we are not considering the working loads, we are considering some of the kinds of loads higher than that, and in what extent we will see in the further slides. So limit state method is to define the maximum load carrying capacity, okay, and the safety requirement for the structures. Again, this method is provided in the section 5 of IS 456 2000. Okay, it is available there. Then, so building is analyzed for the usefulness. Okay, so what is the limit state of serviceability? We will see first. What is the limit state of serviceability? So building is analyzed for the usefulness to prevent the excessive deflection as well as the cracking. Ensure the adequate performance of the structure. Limit state of deflection and limit state of cracking. These two parameters we studied in this limit state of serviceability. Okay, again this serviceability is deals with the this whatever kind of material we are using and whatever kind of workmanship we are using for the designing of any kind of building is this. Okay, then the limit state of collapse. Okay, another parameter in that. Okay, so maximum stress condition of the structure just before the collapse. Okay, what are the different case studies that are available for the failures? Okay, means if we go for the any kind of structure and that particular structure fails on the some of the kind of say load. Okay, you design the structure for this some of the kind of load, and this structure get failed in some of the kind of load. on the slight increasing in the load. In that cases, some of the depending upon these studies, okay, so maximum stress condition of the structure just before the collapse study, these studies should be there. Throughout a structured life, it gives the proper strength and the serviceability by the limit state. Limit state of collapse deals with the safety of the structure. The limit state of serviceability deals with the durability of the structures. Okay. So again, when the durability comes into picture, there will be some of the kinds of, we can say, this workmanship as well as the material. These two parameters are very important. Though the material strength is very good, but workmanship is very poor, they don't know to how to prepare a good mix, okay, then the whole process is just a total wastage of time. Okay, again, whatever kind of, we can say, the serviceability that should be there for the particular structure, there will not be there definitely. Okay, so depending upon these criteria, there must be the we can say adequate this method, we can say this workmanship is also there, and as well as these materials should be also there. Okay, then basic assumptions in the limit state collapse. Okay, limit state of collapse, the stress and distribution is assumed to be parabolic. Okay, it is fine, it is parabolic, it is fine, because in the parabolic nature we are considering this concrete is behave in a different manner, whereas the steel will behave in a different manner. Okay, so this parabolic in nature, or apart from this linear nature, it is fine. Okay, linear nature, it is totally wrong. Okay, see, parabolic nature, it is fine, because concrete and steel are the different materials. Okay, the tensile strength of the concrete is ignored, because the concrete is weak in tension, we all aware. So wherever the tensile nature is there, we are only thinking of the reinforcement. Okay, the maximum compressive load of the structure takes by the concrete. Okay, maximum compressive load is takes by the concrete. The steel takes the maximum tensile load of the structure and takes the little bit compressive stress, load or compressive stress. There should be a perfect bond. If this is the parameter is common for working stress method as well as here also. Whatever structure we assume, the bond between this reinforcement and the concrete, it should be there. If it is not there, it will lower down the, we can say, serviceability of for the particular structure. There will be some of the kind of efflorescence, there will be some of the kind of corrosion, and that will reduce the total life of that particular structure. Okay, so that's why there should be the good bond between the steel and concrete. Then this is the some of the kind of assumption in the limit state of collapse. This is the limit state of collapse in continuation with that. So again, whatever is the kind of major strength that is developed on the upper fiber of the concrete, it is same. Okay, during bending. So during bending, again, we have seen the in the previous slides. So this is the kind of bending, and whatever during this bending, whatever kind of strength available here or generated here, this is the same value that is available in working stress method also. Means whatever is the criteria they opt for, okay, that will provide the in some of the fashion same results. Okay, but whereas the some of the kinds of distinct difference is like in the working stress method, the whatever is the kind of, or what is the size of member is very high, whereas the size of the material, size of the member using this limit state method is very adequate. Okay, then section is plain before bending and remains plain, means like whatever the section here, that whatever the cross section parameter should be is available here, that it should be the same here, that 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 will be the case. Okay, so this is the some of the kind of basic assumptions. Okay, these are some of the kinds of stress relationship. Okay, and how this parabolic wave flows. Okay, that is the formulation. Okay, so it is better to go with this formulation when we are solving some of the kinds of numerical in during this numerical solving session. This formulation as well as this parameter will again will be easy to you for understanding. Okay, so characteristic strength of material, like the strength of material below which not more than 5% results X are expected to fall. Okay, whatever kind of strength for the particular material we assume, okay, not less than 5% of the results should vary. Within 5%, 2%, 3%, 4% variation is there if the strength value is there. Okay, if you cast a concrete and if you test the concrete 3 days concrete cube, 7 days concrete cube, 28 days concrete cube, if you cast a concrete, if you test a concrete, not less than 5% variation should be there. Means in the 3 days cube casting, you should you prepared a 3 sets for 3 days concrete. Okay, and you break the concrete in compression testing machine or universal testing machine. Okay, and you found the results. Okay, so not more than 5% results should be expected to fall. Okay, so these are the some of the kinds of, we can say, that strength value will be the characteristic strength. That strength value will be the characteristic strength for the particular material. Generally, it is denoted by FCK. So CK stands for the characteristics. So FCK, and this is the standard formula. There is some of the kind of deviation. Okay, so some of the kind of derivation uh, when we can say go for this compressor testing, or we can say some of the kind of say uh, universal testing machine. In the universal testing, some of the kinds of the 5% result. Okay, and this some of the kinds of peak value we can observe there, and depending upon these whole studies, these we can say this graph is plotted, and over this study of this all the kinds of graphs, these results comes into picture that 5% of test results are should not be, not more than 5% of results are expected to fall. Okay, so these are some of the kind of concrete mixes, grade of concretes. Okay, so these are some of the kinds of grade of concrete, and these are some of the kinds of specified characteristic strength at 28 days. Okay, so these are the standards. Okay, whatever is the mix is there, 10, 15, 20, 25, 30, 35, 40. The same is the characteristic strength. Means this M10 means the 28 characteristic strength is the 10 Newton per mm square. Okay, just like the M14 is the 40 Newton per mm square, like that. Okay, these are the some of the kinds of characteristic strength value. Okay, so like this. So now this is important. Now this is important because in the previous, this is that will again will we will discuss more, because this is the parameter is important in this limit state approach. This is the important parameter in limit state approach. Like we are using the two factors of safety for the uncertainty of the material and uncertainty of the load. Okay, we are aware. Okay, before that we already discussed that if we are using the material, if the material is specified in the IS code, that is the characteristic strength is the for the particular material is like this. Okay, but it is not sure that whatever kind of material is available on site, that will be same characteristic strength of the whatever the kind of value is provided in the IS code. Okay, so that's why there is a uncertainty in the materials also, and again the uncertainty of the loads also. Again, I have given the example of say 40 students, but in the future maybe the students may increase to 60, maybe sometimes to 80. Okay, so depending upon the use of this, there is the uncertainty of loads. So we have to use some of the kinds of we can say multiplication factor. Okay, to some of the kind of increase to load and some of the kind of to decrease the material strength. Okay, so these are some of the kind of factors, multiplication factor, and that multiplication factors are termed as a partial safety factor. That multiplication factors are termed as a partial safety factor, and these are the factors that are given denoted by the gamma. These are the factors, some of the factors denoted by gamma. Okay, so for concrete it is taken as 1.5, and for steel it is taken as 1.15. Okay, so like wherever we have to decide where to take the characteristic strength of concrete, then we will divide whatever is the characteristic strength is available with us by 1.5. Okay, that will lower down the strength value. Okay, so for materials we are lowering down the value. Okay, or for the loading values we are increasing the values. Okay, so here we are considering the material parameters. So what are the different coefficients that are used for different kinds of material? So these are those parameters. Okay, so possibility of deviation of strength of material. Okay, deviation of the sectional parameters, as well as the accuracy of the calculation procedure. Okay, and risk to life and economic consequences. So depending upon this all these criteria, these we can say partial safety factors are comes into picture. Okay, then Partial factors of safety for loads are taken into consideration to accommodate the following points. Unusual increase in load. Okay, we are aware that we have to increase the load than the actual value. Okay, अनफोर्सिन दी स्ट्रेस डिस्ट्रीब्यूशन, मतलब इसके पहले अब कभी नहीं हुआ ऐसा कोई स्ट्रेस रिलेशनशिप आपको अगर देखने को मिला, अगर वो दैट शुड नॉट बी द केस इन फ्यूचर. Okay, to should not be happening the, again repetitive work should not be there. So for that situation also we should increase the load. Okay, inaccurate assessment of the effect of loading, maybe it is again the part of say malfunction of that particular, we can say, engineer. Okay, whatever is the load he calculated at that time, it may be some of the kind of say faulty values, or we can say the faulty workmanship by that particular engineer, maybe, or some of the kind of accuracy is not there. Okay, so depending upon these all the parameters, there may be some of the kinds of the fluctuations in the loads. Okay, then these are some of the kinds of, we can say, partial safety factors. When we have to design our structure in case of limits of collapse, so in this case we will consider these factors. And when we have to design this structure for the serviceability aspects, then these are the coefficient that are used to increase the loads. Means like this, say this is the load cases 1.5 sorry, dead load plus live load. Okay, so 1.5 dead load plus 1.5 times live load, or this we can write at dead load plus live load into say 1.5. Okay, so like this. Okay, so like if dead load plus wind load, this WL stands for wind load, or say earthquake load, then again there will be the parameter, there will be the coefficient of 1.5. Okay, then again if there is some of the kind of dams, there is some of the aspects of overturning is there, then in that case we have to multiply with zero point 0.9. So depending upon these there are some of the kinds of different combinations are there, and for different combinations, if individual we have to consider, then 1.2 will be the multiplication. Okay, and similarly if I would consider the serviceability, then these will be the coefficient. Okay, so these are the means, by multiplying these we will increase 1.5 times the actual load value. Okay, so for the particular dead load live load, we are increasing the particular actual value 1.2 times. Okay, so like these are the some of the kinds of multiplication factor, and that multiplication factor are termed as the partial factor of safety. Okay, so that are the these this is okay. So I suppose this is fine for today. Okay, so design of beam, in short I will tell the design of beam. Okay, then we will stop. Okay, another 5 minutes. Then a singly reinforced beam. Okay, so there are, see, in the design of beams there are two types of beams, singly reinforced beam and doubly reinforced beam. Okay, so basic purposes of these two types of beams are different. Okay, now see, if I have to go for the beams of size 300 by 450 mm. Okay, if I have to go for the size of 300 by say 450 mm. Okay, but but depending upon this structure, depending upon the whatever is the load is coming on the particular beam, okay, I have to go for this 300 by say 600 mm. Okay, but depending upon the, we can say, the whatever is the location is there, and at that particular location the size of beam is not like, we can't go for the this size, I have to go for this size. Then by using this size I have to provide the strength of this beam. By using this size I have to provide the strength of this size. In that case we will use the doubly reinforced beam. Okay, so where the cross sectional parameters are limited to us, okay, where there will be some of the aspects are there, lack of spaces are there, and we have to provide the whatever the strength is available for 300 by 600 beam, but we have to go for this 300 by 450 beam, then in that case we should go for the doubly reinforced beam. That will solve our task. Okay, that will be the solution over this question. Okay, then in the singly reinforced beam, whatever the kind of beams we have provided in the previous slides, these all are the singly reinforced beam. This is the singly reinforced beam. Whereas In the doubly reinforced beam, the sorry, in here same cross sectional बनाऊंगा. Okay, so same cross section. Again, this is some of the kind of reinforcement, and this is some of the kind of reinforcement. So this comes under the doubly reinforcement. Okay, again, the whatever is the B and D and small d and capital D will be same. Okay, so like these are the hand here there will be some the kind of 2D. One D will be the from the bottom fiber, and another D will be from the top fiber. So D1 and D2 will be there, so some of the kind of D1 and D2 will be there. But whereas here in the singly reinforced B, there will be only the D. Okay, again, the overall diameter for both the beams will be the same, the capital D. Okay, so like these are the some of the kinds of, we can say, types of beams: singly reinforced beam and doubly reinforced beam. Okay, in first of all, we will see the singly reinforced beam. In singly reinforced beam, there will be some of the kind of, say, balance section, under reinforced section, and over reinforced section. Okay, so like balance sections are those where the stresses in concrete and steel will reach at the maximum values at the same time. Means whatever is the beam is there. Okay, and if I consider the stress value, okay, so whatever is the stress value we have, that will be the same. Means whatever is the this triangle and this triangle will be same. So we will assume this is the balance section. Is whatever is the stresses developed in the steel, that will be the same stresses developed in the concrete. That will be the balance section. Means theoretically we assume this all the sections are balance section, but in the reality this is not possible. Okay, this is not possible. In this case, this xu as well as xu max will be same. What is xu? This xu is like, this is the neutral axis for the balance section. Okay, and xu max is the actual neutral axis for the actual example. Okay, in this case, for the balance section, your your theoretical neutral axis as well as your practical neutral axis will be same. Okay, but that will not be the case, we all aware, because we have seen the all the assumptions, and depending upon these assumptions, the different kinds of design are based. Okay, again, this xu can't equal to xu max. Okay, under reinforced section. In under reinforced section, whatever is the stress generated, the steel section will is less than the steel in the section is less than the provided in the balance section. Whatever is the requirement of steel is available for balance section, we will provide the lesser steel. Okay, in this particular section. Okay, so whatever is the steel, when the load comes into that particular structure, so steel will fail first, because whatever is the quantity ideally required, we are providing the less quantity than this. Okay, so first of all, steel will fail, and again this will be a ductile failure, and during this failure there will be some the kind of warning they will provide. Okay, and most of the section are of this under reinforced section, so very common. So under reinforced section, how, what are the different kinds of section that are we are practically providing, that all are the under reinforced section. Okay, so again the xu will be less than the xu max. Xu is less than the xu max. Okay, now over reinforced section. In the over reinforced section, whatever kind of reinforcement we provide in the balance section, the sorry, so value more than the that value we will provide. Okay, value more than this value we will provide. Okay, but this is more dangerous. This is more dangerous because we are providing the steel value more than the permissible value. Means whatever kind of stress that will develop in the concrete first. Again, concrete will be weak in tension. Okay, concrete is a brittle material. Means steel fail होने के पहले concrete fail हो चुका होगा. स्टील फेल होने के पहले कंक्रीट विल फेल ऑलरेडी, और जब तक स्टील फेल होगा तब तक काफी समय जा चुका होगा. दैट इन दैट केस दिस सेक्शन अगेन विल फेल सडनली. ओके, means you will not observe this we can say the duration of this failure, because concrete from inside the concrete will fail already. Okay, and wherever there is a major fail is there, the whatever time they require, that is a very small. Okay, so this is again, this is the not the, we can say, the feasible, we can say, the section. Okay, so feasibly or in a practical purposes, we go for the under reinforced section. That is the most safe section, safe material. Okay, so this is for today. Okay, apart from these singly reinforced beam design parameters, as well as this doubly reinforced beam parameter, we will discuss in another lectures. Okay, so that's for today. Okay, thank you for providing me this opportunity, and thank you for listening very patiently. Okay, so thanks. And also I am very thankful to Shefali ma'am for providing this opportunity to me to provide such kind of teaching learning process in this teaching learning process for these gate aspirants. Okay, as well as I am thankful to our your college also for providing me this opportunity. Okay, so once again I am very thankful to all of you. Thank you. Any question is there, please ask.
Student, if you are having any question, you can ask. Okay, sir. Thank you so much for delivering such a wonderful lecture. Thank you so much for giving your valuable time for for our students. Thank you very much, sir.
Okay, okay, thank you ma'am. Okay.